think there was a very interesting 2015 paper by Google. It's called The Hidden Technical Debt in Machine Learning. You might have seen that infographic. So there's
Yes.
like so many other modules. It basically the figure depicts an ecosystem of different technology stacks, not technology stack, like different modules in the machine learning pipeline. You got like feature ingestion, feature processing, feature engineering, data quality monitoring, and then the model itself is like this tiny, tiny little rectangle, the overall sort of architecture, right? The where I'm getting at with that sort of process is like you have to really the machine learning engineer, you have to really understand what is the source of your data. Where does your clickstream events come from? Or where does your supply chain data come from? What generated it? Is there any sort of like interference in the processing that might bias your samples? Like, are you only collecting clicks or are you only collecting one type of data versus the other? And then same thing with like the downstream. How are your model predictions getting used? In the case of recommender system personalization, it's most likely your model predictions are directly put in front of the customers, right? You have a front end that renders your ranking somewhat, maybe filters it away for duplicates or something, but in general, there's not a lot of interference in the model predictions before it reaches the customer, but that may not be true with many of the backend sort of internal tooling or other types of non-customer facing ML use cases. So think through on how the downstream integrations happen. Are there post-processing layers that might invalidate how you generated the result? So I'll give you an example of there was an interesting use case where the marketing team was like, well, we really need model explainability, right? And then I mean, if I was a junior engineer, like looking back at myself 8 years or 10 years ago, I would be like, sure, I'll give you a feature importance. But now I'm like taking a step back. Why do you need model feature? Like, why do you need model explainability? What does that help you with? Right. And they're like, well, if I know which attributes in the model are helping to generate those predictions, then I can like tweak something and then like re-engineer the system to do that. But I'm like, hold on, I don't think you need this extra two-step process to get feedback on feature importance if and then try to like fine-tune it manually. We can do that in an automated system by retraining the model by looking at the same feedback data,
Yes.
right? So you don't need an extra step. So I was just using that as an example to say, really understand your downstream and upstream process.